This video focuses on how the ANOVA test statistic is calculated. Researchers studied whether different instructional methods result in differences in mean fitness. The independent variable is instructional method, and the dependent variable is performance on a test of physical fitness given at the end of the school year. 12 students were assigned to each of the instructional methods for a total sample size of 48. The between groups degrees of freedom is 3, and the within groups degrees of freedom is 44. We're going to calculate the SS, MS, and F values from this SPSS table. There are two sources of variability in an ANOVA design, between and within groups. Our first calculation involves sum of squared mean deviations, or sum of squares. This is the formula for the between group sum of squares, when the sample size is the same for each group, as in this example. J is just keeping track of the groups, from 1 to k, where k equals the number of groups. X bar sub j is the mean for group J, and X bar is the grand mean, the mean across all subjects. This formula says, for each group, subtract the grand mean from the group mean, and square the difference. Sum these values across groups, and then multiplied by n, the number of observations in the group. Here's the formula for the within groups sum of squares. Starting with the inner summation equation, for each group, subtract the group mean from each score, square the difference, and then sum all the squared differences. Next, sum these squared mean deviations across the groups. Here are the descriptive statistics for the fitness study. These values are the sum of squared mean deviations within each group, found by taking each score in the group, subtracting the group mean, squaring the difference, and then summing these squared differences. So we have the inner summation of the formula, the sum of squared mean deviations for each group. Applying the outer summation sums these values across groups. Here's the formula for the between group sum of squares. X bar sub j is the mean for group J, and X bar is the grand mean. N is 12. Plugging the data into the equation, we get a between group sum of squares of 15,222. So the between group sum of squares is 15,222, and the within group sum of squares is 8,490. We need one last set of calculations called mean squares. In ANOVA, the variance terms are referred to as mean squares. The between group mean squares is calculated by dividing the between group sum of squares by the between groups degrees of freedom, and the within group mean squares is found by dividing the within group sum of squares by the within groups degrees of freedom. Putting the between group data into the formula gives us the between group mean square of 5,074. Doing the same for the within group data, we get the within group mean square of 192.95. Now we can calculate the test statistic F. In ANOVA parlance, it is the ratio of mean squares between to mean squares within groups. Putting the data into the formula, F is equal to 26.3. The larger the F value, the greater the departure from the null hypothesis, since the treatment effect shows up in the numerator. Returning to the SPSS output, this is how the mean squares were calculated, and this is how F is calculated. The p-value is small, so the null hypothesis is rejected. To summarize, ANOVA partitions variance into two parts, between and within groups. The F statistic is a ratio of between to within group mean squares, or variances. Mean squares are calculated by dividing the appropriate sum of squares by the appropriate degrees of freedom. The larger the value for F, the greater the evidence against the null hypothesis.